2026 A-Level Physics Paper 1, questions 1 up to 10. If you are interested in any of the other questions from question 11 up to question 50, then check out the links in description down below. Now moving on to the first question says, which of the following pairs does not have similar dimensions? Now out of these we look at the first answer. The first answer is stress and pressure. Now stress here is equal to the force per unit cross-sectional area of an object to which a force is being applied. And due to the units here are newtons divided by meters squared. Now next, if we consider pressure is usually given in pascals. However, since pressure is also equal to the force per unit surface area of an object, we can also write its units as being equal to newtons divided by meters squared. Now since these two units are both equal to each other, the dimensions of these two must also be equal to each other. And therefore, if the dimensions are equal, the answer stress and pressure must be incorrect, since we are looking for the ones that do not have the same dimensions. Now next we consider answer number 2. Answer number 2 has momentum and impulse. Now momentum is equal to the mass times the velocity of a moving object, and therefore has units of kilograms times meters per second. Now if we consider impulse is defined as the change of momentum, delta momentum. Now since these two are directly proportional, they must have equal units, and therefore if the units of impulse are also kilogram times meter per second, then we can say if the units are equal, the dimensions must also be equal, and therefore answer number 2 is also incorrect. So answer number 2 is also incorrect. Now moving on to answer number 3. Answer number 3 has force and surface tension. Now force here has directly the units of newtons. However, surface tension, which uses as a symbol of T, has a specific definition which is defined as the force per unit length to one side of an imaginary line drawn on the surface of a liquid to one side of that liquid perpendicular to that line. Now considering that, if we take a look at the definition, we can see there's a key point which says it is equal to the force per unit length on that line. And due to that, the units of surface tension are newtons per meter. Now since these two units are not equal, as one of them has a factor of 1 over meters, we can see since the units are not equal, the dimensions must also not be equal, and therefore force and surface tension don't have the same dimensions, which means it's the correct answer for this question. So we can say the answer here is answer number 3. Now for completeness, let's take a look at the other two answers. The fourth answer has speed and velocity. Now both of these have units of meter per second, since both of them represent the same basic quantity, distance per unit time. The only difference between these two is that speed doesn't have a necessary direction. However, velocity has a specific direction, since velocity is a vector quantity while speed is a scalar quantity. So therefore, answer 4 is also wrong. Now finally looking at answer number 5. Answer number 5 has work and energy, and both of these have the same exact dimensions. The reason is, if you consider work done is equal to force times distance, which has units of newtons times meters, which you simplify to SI units, is going to be equal to kilogram meter per second squared times meters, which is kilogram meter squared per second squared. If you then consider energy has units of joules. And considering the joule, since kinetic energy is equal to half mv squared, if we apply the units, we can see m is equal to kilograms, v is equal to meter per second, so we have meter per second squared times kilogram, which gives us kilogram times meter squared times per second squared. And due to this, since the two SI units of these two are equal, we can also say the dimensions are equal, and therefore these two are the same dimensions and are not the correct answer. So with that, we have answer number 3 as the correct answer and can now move on to the second question. So moving to the second question is about vernier calipers. The question says, the diagram shows a reading of a certain length taken using a vernier caliper, and given this they ask us, what are the measured length and the least count of the instrument respectively, given that the vernier caliper has no zero error. Now looking at the vernier caliper, we can see usually in between 0 and 1 we would have 1 centimeter, and here we have 10 small divisions. Therefore on the main scale, the 1 division is equal to 0.1 centimeters. Now next we look at the vernier scale, we can see we have 10 large divisions measured. However, in between each of them we have another division. So in between 0 and 1 there's one more division, in between 1 and 2 there's one division, and so on and so forth. So therefore we have 20 divisions on the vernier scale. Now those 20 divisions match up to 19 divisions on the main scale, and due to that, the ratio here in between a main scale division and vernier scale division is equal to 20 minus 19 divided by 20, or 1 over 20. So therefore, one of the vernier scale divisions, and therefore the least count, is going to be equal to 0.1 means, or rather one of the differences between the main scale and vernier scale divisions is going to be equal to 0.1 centimeters of the main scale division times 20 minus 19 divided by 20. Therefore, the answer here is 0.1 centimeters times 1 over 20, which if you do the math is equal to 0.005 centimeters, or 5 times 10 to the minus 3 centimeters. Now according to that, if we look at the answers, we can see these three answers are incorrect since each of them don't have 0.005 centimeters. So this is wrong, and this is wrong. Now looking at the other two answers, answer number 2 and answer number 4, we have 12.06 centimeters and 12.60 centimeters, or rather 1.206 and 1.260 as the 2 centimeter answers for the length measured. Now looking at the vernier scale, we can see these two align at this point right here. You can't really see it. If I zoom in, you'll see it. The vernier and main scales align at 6 right here, or at least they're supposed to. Now if they align at 6, we can see we're going to get 6 total large divisions on vernier scale, which is 12 total divisions, since in between each of them we have another extra division. So we have 0, 1, 2, 3, 4, 5 all the way up to 12 divisions on the vernier scale. So due to this, we have 12 times 0.005 centimeters, or 0.06 centimeters of vernier scale length. Now if you look at the main scale, we can see the 0 here is right past the 1.2 mark on the main scale. So due to that, the main scale reading is 1.2, so therefore we have 1.2 plus the vernier scale reading of 0.06 for a total of 1.26 centimeters on the vernier scale. And therefore the final answer here is 1.26 centimeters and 0.05, or answer number 4. Now moving on to the third question. The third question says, as shown in the figure, two blocks of mass 4 kg and 6 kg are placed in contact with each other on a frictionless horizontal surface. If a horizontal force of 5 newtons is applied on the heavier mass so the system moves together, what is the magnitude of the force that is acting on the lighter mass? So here we can see we have 6 kg, 4 kg and a force acting of 5 newtons to the right hand side. Now if these two objects move together to the right hand side, we can see there must be a normal reaction from the 6 kg mass on the 4 kg mass, pushing it to the right like so. And due to that, there's going to be an equal and opposite force on the 6 kg mass, stopping it from accelerating in that direction like so. Now due to this, if we consider the 4 kg mass, if the 4 kg mass moves with the 6 kg mass with the same acceleration like this, then both of them will move together, and if we apply F equals ma to the whole system, on the left hand side the total force here is 5 newtons, which will be equal to the total mass times the acceleration, which is equal to 6 plus 4, or 10 kilograms times A. And due to this, we can see A is going to be equal to 5 over 10, or 1 over 2 Newton per kilogram, or meter per second squared. So this is the acceleration of both of these blocks. Now if the second block is accelerating like this with 1.5 meter per second squared acceleration with a force R, then if we apply F equals ma to that block only, we should get F equals ma, which is R equals 4 kilograms times 1.5 meter per second squared, which gives us that the reaction R is equal to 4 divided by 2, or 2 newtons. So therefore, the force here acting on the smaller block is equal to 2 newtons, which is what the question is asking, and therefore the answer here is 2 newtons. Now moving on to question number 4. Question number 4 says the speed of sound in air and gives us 5 answers. And out of these 5 answers, one of them is correct. Now in order to answer this question, we need to know that the speed of sound in air V is given by 2 formulae. One which is equal to the square root of P over rho, where P is pressure and rho is density, and the other one where the velocity of sound is equal to the square root of RT over capital M, where R is the ideal gas constant, T is thermodynamic temperature, and capital M is the average molar mass of the gas. Now we can switch between these two using the ideal gas law. Now according to this, we can see immediately answer number 1 is incorrect. It's incorrect because it says the speed of sound in air is independent of temperature, when clearly in the second formula, it is clearly dependent on temperature. So therefore, number 1 is wrong. Now moving on to number 2. Number 2 says it increases with increasing pressure. Now looking at the first formula, we can see this looks correct because if you increase the pressure here, the square root of that number will be bigger and therefore the value of V will be bigger. However, this is not 100% correct. It's not correct because if you have a constant temperature and you take a gas and increase the pressure, increasing the pressure will compress the gas, and because of that, the density of the gas will also increase. So due to this, if you have a constant temperature T here and you increase the pressure, the density here will also increase by the same exact value. Due to that, the ratio of pressure and density will still remain constant. And because of this, just increasing the pressure is not a guarantee of increasing the speed of sound in air. So due to that, we can say increasing the pressure will not necessarily increase the speed of sound in air. And similarly, it will not also decrease the speed of sound in air. So that's also wrong. Now moving on to the last two say it decreases with increasing humidity and it increases with increasing humidity. Now humidity here is the concentration of water vapor in the air. Now considering water vapor is made of water molecules which have the formula H2O and are basically one oxygen atom and two hydrogen atoms connected like so. Now if we consider normal air is mostly made of nitrogen gas and oxygen gas. It's about 80% nitrogen and 20% oxygen. Now considering nitrogen and oxygen, nitrogen has a molar mass of 2 times 14 or 28 grams per mole. And oxygen has a molar mass of 2 times 16 or 32 gram per mole. However, if we consider water vapor has a molar mass of 2 hydrogens and 1 oxygen, which is 1 plus 1 plus 16 or 18 gram per mole. Now according to this, we can see the density of water is going to be lower than the density of nitrogen or oxygen gas in the gaseous state. Due to this, if we consider capital M here, the actual average molar mass of the gas will decrease when we introduce more water vapor into the system. So due to this, when the humidity increases, the concentration of water vapor will increase, decreasing the overall molar mass, and due to that, in this formula, the denominator will decrease. So RT remains constant, however the denominator decreases, and if the denominator decreases, then the overall value of the formula here will increase. If you take the square root of the number, it will still increase. Therefore, if we increase humidity, we'll end up reducing the overall molar mass, and therefore we'll end up increasing the speed of sound in air. So from this we can say answer number 5 is correct, since it says when you increase humidity. So from this we can say answer number 5 is correct, since it says when you increase humidity, the overall speed of sound in air will increase. So answer number 5 is the correct answer. Now moving on to question number 5. Question number 5 says the total energy of a particle undergoing simple harmonic motion is directly proportional to one of these answers. And the answers are velocity, velocity squared, amplitude, amplitude squared, and frequency. Now in simple harmonic motion, since our velocity is constantly changing, the answer cannot be velocity or velocity squared. Now out of the other answers, the correct answer is the square of the amplitude. To understand why, let's consider simple harmonic motion. So in any simple harmonic motion, you need to understand two important points. The first one is that at the center of oscillation, the velocity of the particle is maximum. We have Vmax at this point. The reason for that is that at this point, the potential energy of the particle is equal to 0. And due to that, the acceleration is equal to 0. And therefore, all of the energy, E total, is in terms of kinetic energy. Now from this we can say E total is equal to half m times velocity max squared. Now the other point we need to understand is that at this other point, which is the amplitude point, the velocity is equal to 0. And at this point, 100% of the energy is stored as potential energy. Now in simple harmonic motion, we have an equation V equals omega times the square root of a squared minus x squared, where omega is equal to the angular velocity of simple harmonic motion and x is equal to the distance from the center of oscillation. And we can see at the maximum distance, which is the amplitude, we get a squared minus a squared, which is 0, times omega, which is 0. And therefore, at this point, the velocity is 0. Now, this also means that at the center point, which is the point at which we have maximum velocity, our x value is going to be equal to 0. And therefore, we get Vmax being equal to omega times the square root of a squared minus 0, which is a squared, which is going to be equal to the square root of a squared, which is going to be a. And therefore, we get Vmax equals omega times a. Now, if we substitute this into this expression right here, we can see we have 1/2 m omega squared a squared. And from this, we can see the total energy is proportional to amplitude squared. Now, we also have a frequency in here because we can see omega is equal to 2 pi over f. And therefore, omega squared is equal to 4 pi squared divided by f squared. And therefore, the total energy is also equal to the inverse square of the frequency. So in this case, since we don't have that inverse square of the frequency, our answer is square of the amplitude. And therefore, the answer to question number 5 is square of the amplitude. Now moving on to question 6. Question 6 says, how many types of quarks exist? And the answer here is 6. So the answer here is answer number 5. The 6 quarks are the up quark, the down quark, the strange quark, the charm quark, the top quark, and the bottom quark. So those are the 6 total quarks. So with that, the answer for question number 6 is 6. Now next, if we consider question number 7, question number 7 says, the two waveforms shown in the figure are traveling in opposite directions in a medium along the same plane. And given this, they ask us, what is the shape of the resultant waveform when the point O reaches the point C? So these two waveforms are traveling like this, and they will eventually meet. Let's call the left waveform waveform 1 and the right waveform waveform 2. Now what they're saying is, the point O on waveform 2 will eventually superimpose with the point C on waveform 1. And when that happens, what is the resultant waveform? Now to figure this out, let's take one of the waveforms and move it such that the point C and the point O are superimposed on each other. So we'll draw the point and the waveform of the wave 1, and let's take that waveform and move it such that this point C overlaps with the point O. And we can see these two waveforms will interact like this. So now considering the resultant waveform, in waveform 2, we have this segment right here which does not interfere with waveform 1, and therefore it will remain as it is in the final waveform. Next, if we consider this middle section, in the middle section there is interference between waveform 1 and waveform 2, and the interference is destructive. Due to that, waveform 1 and waveform 2 will cancel out each other, leaving us with 0 amplitude in between these 2 points. So in between the point C and this point, which is going to be B, we'll have 0 amplitude. Now finally, if we consider the last area, which is this region right here, we can see in this region there is only waveform 1. So waveform 1 and waveform 2 don't interfere, and therefore we will have a segment like this in this third region. So we'll have an upward segment here, 0 amplitude due to the destructive interference here, and another upward segment over here. So therefore the answer here is answer number 4. Upward segment, destructive interference, upward segment. So answer is answer number 4. Now moving on to the next question. Next question says, which of the following is the suitable device for the most accurate measurement of the EMF of a cell? Now considering this, we can see immediately galvanometer and ammeter are both wrong, since both of them measure the current. So they are wrong. Now considering the remaining, the correct answer is potentiometer. Meter bridge is wrong because meter bridge is used to measure resistance, and the other one, non-ideal voltmeter, is wrong because a non-ideal voltmeter is a voltmeter that will draw some current. And when you draw current from a cell, if the cell has an internal resistance, then we are going to get on the outside for this voltmeter not the EMF E, but rather V equals E minus IR, where I is equal to the current drawn. So due to that, the non-ideal voltmeter is also wrong because it will not give us exactly E. It will give us E minus IR. So that's also wrong, meaning the final answer is answer number 5. And the reason the potentiometer is correct is because the potentiometer does not actually draw any current from the cell. It works at a point when the current drawn from the cell is equal to 0. Now next, if we consider question number 9, question number 9 says, a uniform solid sphere starts from rest and rolls without sliding on an inclined plane. Now, if this thing rolls without slipping, it means any distance traveled is equally rotated along the surface of the sphere. So due to that, if we have a distance d here and we have an angle theta traced when our sphere rotates that distance, then this d will be equal to the circumference length here, and therefore if we have theta here and r here, d will be equal to r theta. Now after the question then says, the moment of inertia I of a uniform solid sphere of mass m and radius r rotating about an axis that goes through the center is I equals 2/5 mr squared. Now given this information, we are asked what is the ratio of translational or normal kinetic energy of the sphere to the rotational kinetic energy of the sphere. Now let's consider a rolling sphere. If we have a rolling sphere like this that's rolling down an inclined plane, it's going to have velocity v. Now considering this velocity v, since it's not slipping, if it rotates a certain distance, the same distance will be rotated across the angle, and therefore if it has an angular velocity omega, omega will be equal to v divided by the radius. So we have this equation right here. Now considering this information, we know directly that the translational kinetic energy TKE is equal to half mv squared. Now additionally, we also need to find the rotational kinetic energy. Now RKE is equal to half I omega squared, very similar to half mv squared. And into here, we have to substitute the value of I, which is equal to 2/5 mr squared, so times 2/5 mr squared, and then times omega squared, which is v over r whole thing squared. So times v over r whole thing squared, or v squared over r squared. And we can see these two will cancel, leaving us with 1/5 mv squared. So rotational kinetic energy is 1/5 mv squared, and translation kinetic energy is 1/2 mv squared. Now dividing into, we can see we have 1/2 mv squared divided by 1/5 mv squared. These two cancel, leaving us with 1/2 divided by 1/5, which is 5 times 1/2, or 5/2. So therefore the final answer here is 5/2. Now moving on to question number 10. Question number 10 says, consider the following statements about electric equipotential surfaces. So statement A, the first statement says, the electric field intensity is always constant over an equipotential surface. Now while this can be true in some specific situations, specifically when you have a symmetrical surface, it will not be true in the general case. In the general case, the only thing that is always constant over an equipotential surface is by definition the electrical potential. Nothing else is generally equal across an equipotential surface. Now moving on to statement B. Statement B says, the electric field lines and equipotential surfaces are always mutually perpendicular. Now the reason for this is that if they weren't perpendicular, if you had like a surface like this and an electrical field line like this, you would run into contradictions. So to explain the contradiction, let's consider these 2 points. I'm going to call their potentials V1 and V2. Now since these two are the same equipotential surface, V1 should be equal to V2. However, since we have an electric field line here that passes like this, going from V1 to V2 should change your potential, and therefore V1 cannot be equal to V2. Now these two are a contradiction. You cannot have V1 equals V2 and V1 not equals V2 at the same time. So due to this, you can never have an electric field line being non-mutually perpendicular with an equipotential surface. So therefore, since it says that they are always mutually perpendicular to each other, we can say statement B is true. Now moving on to statement C. Statement C says, no two equipotential surfaces intersect with each other. Now this one's also true and can be proven true by contradiction. So let's consider two equipotential surfaces like this. Let's say this one's potential is V1 and this one's potential is V2, where V1 is not equal to V2. Now considering that, let's take a look at the intersection points. So at this point, according to this field, we should have this point potential being equal to V1. However, according to this one, we should have this point potential being equal to V2. Now since V1 is not equal to V2, we cannot have V1 and V2 both being the potential of this point. Therefore, we have a contradiction, and therefore, no two equipotential surfaces can intersect each other. Only the same equipotential surface can go through a single point. So therefore, the correct answers are A is wrong, B is correct, and C is correct, which gives us B and C only as the correct answers, which means the only correct answer here is answer number 4. B and C are true. And with that, we are done with question number 1 until question number 10. So I hope you enjoyed. If you have any questions or feedback, then post them in the comments down below. Thank you for watching, and goodbye.